When it opens up, it's going to look like this. And you're going to have some circuits you need to build. So, for example, here's the assignment. And it says to build this circuit here. So I'm going to move this out of the way because I don't have room for both of them at the same time on the screen. But let's build that circuit in MultiSIM. Over here, we have drop-down menus of different electrical and electronic devices. If you know what digital logic is, these two drop-down menus are for digital logic, which we're not doing this assignment. This one is for operational amplifiers. Maybe you've heard of op amps before if you do electronics as a hobby. It's a very popular amplifier that's easy to use. And so it's used for a lot of different things, comparing signals and amplifying small signals, things like that. Under this button will be transistors. Under this button will be diodes. Under this one, that little squiggly line is a resistor. So all the basic electric components, these are all electronic over here. The electric components that don't have semiconductor material, resistors, capacitors, inductors, transformers, things like that, they will all be underneath this one. And where you see the ground symbol, that's all your power. So what we need to do is first is have a battery. I'm going to click on that one and come down here. And we want a power source. I'm going to click on that. A battery is a DC power source. There's the symbol for a battery. So I'm going to click OK, and that will let me bring it over to the workspace, and I'm going to click it right about here. The instructions say use a 12-volt battery, and this one already is, but I'll show you how to change it in case you need to, and you will need to change it for some other circuits. So let's close that menu for a second. You come over to the battery, you right-click on the battery, and come down to Properties. And here's all the properties you can change. The one we're interested in is already highlighted. It's the values. It's 12V for 12 volts. If you want it to be 6 volts, just change the 12 to a 6, and that 12 here will change to a 6. Let's do that. So there's 6, and I say OK, and see it changes to a 6. Okay, we also need a ground symbol. So I'm going to come over here to power sources again and find ground. Now the reason you need a ground symbol on here is to show the simulator where 0 volts is, because it's going to make all of its voltage measurements compared to wherever you say 0 is. So if I put my probe on some wire and it says it's 5 volts, 5 volts is a potential difference. You're always subtracting one voltage from another to get the voltage value that your meter shows. So the ground symbol is going to go on the wire to 0 that we're comparing all the other wire voltages to. So there's the ground symbol. I'm just going to put that down here in the corner for now. We'll move to where it needs to be in a second. We need 3 resistors. So I'm going to close this one and come over to the basic electrical parts. And we want a resistor, so scroll down there till we find resistor, that's it. And you can pick all these values. The values they want you to use in this first circuit are 1K, that's 1,000 ohms. So we need 3 of those, and it's already highlighted for 1,000 ohms. If it wasn't, you could just slide that, pick the one you want. Here's 825, I'm going to use 1K. So I'm going to bring that resistor into the workspace. I'll put it right there. And I need another one. So I'll say OK, and I'll bring that one over here. And I need one more, so I'll say OK, and I'll bring that one over here. Now they're already all 1K, so we don't need to change the value of those. I'm going to close that. And then we need to connect the wires together. An electric circuit is a closed loop where charges come out of the battery, it runs through all the circuit components, and then it comes back to the other side of the battery. So we need to give it a path for that current to follow, and in this case, it's going to be a wire. So if I move my cursor right at the top of that, there's a little dot up here. And if I left click, I bring the wire to the first resistor and then let go of the button. Oops. And it connects. And then I do the next one. And I do the next one. And I need to bring that one around over here. Now, I can hold that button like I have been and see it kind of routes it automatically for me. But see, if I want to come down here and then go up, I can't. So the other way you can do that is click on that dot and let go, and then draw the wire out to where you want to make a bend. Left click again, and then bring the wire down to where you want to make a bend. Left click again, drag the wire over, left click again, and we're back there. So here's our complete path for our circuit. Now we're going to measure current with this one. If we measure voltage, we put one lead on one wire and the other lead on another wire, and it will tell us the difference in voltage between those 2 points. So here's our 0 volts. So we need to bring that up here because I want this bottom wire to be the 0 volt wire, the 0 volt reference. And so I'm going to connect that ground to...
Does it need that if you're connected directly to a battery?
I'm sorry?
Does it need that if you're connected directly to the battery?
Yeah, because it doesn't know that that's 0 volts. I mean, this could be 0 volts and that could be -6 volts, right?
No,
I could put 0 volts right here. So the negative terminal of the battery is not necessarily 0.
In this case, it would be even without it, though.
No. You're just assuming that because in your experience, it usually is like that. But what happens if you want a -6 volt battery? -6 volt source. You put the ground up here, and now that's -6 volts down here.
Okay, I see what you're saying.
Yeah, so you need to tell the simulator where 0 volts is. Now, your point that usually ground is the negative terminal of the battery, that's usually true, but not always. And because a circuit simulator should be able to model many different kinds of circuits, it gives you that flexibility, and it will not assume that ground is right here unless you tell it it is. Now, here's another thing that students sometimes get have trouble with. They know that the charges flow out of the battery and they come through the resistors, and they come back here, and a lot of people are somehow they've been taught a myth, or they've been indoctrinated incorrectly, or I don't know what it is, but a lot of students think the current is going to go down to ground like it's a drain of some kind. Here's the water coming down, and it all goes slurping down here into ground. No, that doesn't happen. It's going to go back to where it came from. It came from the battery. It's going to go back to the battery. This is not a drain that sucks all the current down. This is just an indication of where 0 volts is. Okay, if we wanted to measure voltage, we could come over here on the, I don't know if you can see that under my picture or not, but there's you see all these little instruments. The one, because I can't see the screen the way you do. I know my picture's up here somewhere, but I don't know what it's covering. If I click on the multimeter and I bring it down, and I want to measure voltage, so I'm going to put it right there, I can put one wire of my multimeter on that side of the resistor, and I can put another wire over here. Now, if I run this simulation, it will compare the voltage of this wire with the voltage of this wire. Now, this is not 0 volts. We know that this one is 6 volts compared to 0. We don't really know what this one is, but our meter will tell us what the difference is. So 6 minus whatever voltage drops across this resistor, whatever is going to be the difference there between this wire and this wire. So if you measure voltage, you're going to measure across something. When you're measuring voltage, the current does not flow through, well, you don't want it to flow through the meter, because if I put a meter here in parallel with the resistor and some current flows through the meter, That means that not all the current's going to flow through the resistor anymore, and that will change the voltage reading. So what you're going to want to make sure you do when if you buy your own instruments is get a voltmeter that's got a very high internal resistance. If the resistance is very high, then only a trickle of current will flow through that voltmeter. Most of it will continue to flow through the resistor, and you'll get a pretty accurate reading. If you buy a really cheap voltmeter with a low resistance, then a significant amount of current is going to flow through that low resistance. It's going to bypass the 1,000 ohm resistor, and your voltage reading will not be accurate because when the meter's connected, the current through the resistor is different. The other thing you can measure is current. So I'm going to delete this wire right here and get another multimeter. Oops, that's not a multimeter. There's a multimeter. Now, multimeter can measure voltage, current, and resistance. That's why I call it a multimeter, because it meters multiple different things. In order to make a current measurement, bring that down a little bit. In order to make a current measurement, all the current must run through the meter so it can measure how much current is flowing. Now, if I measure the current between these two resistors, it will be the exact same current as what comes out of this wire. It'll be the exact same current as what flows in this wire, because every time a charge comes out of the battery, it's got to go through that circuit and come back. So it doesn't matter anywhere in this series circuit where you measure current, it'll always be the same. But we want the current to flow up to the meter and then back down into the rest of the circuit. So we're going to connect that like this and connect that one like that. So all the currents can go through the meter and around. Now, if the voltmeter needed to be a really high internal resistance to prevent very much current from flowing through it and changing the circuit, we want the ohm meter, the multimeter set to measure current, to have a very low internal resistance, because if it's got a significant resistance, it's like adding another resistor here, and that changes the circuit. So the closest we can get to zero, the better. So if you buy a cheap meter, it'll probably have a resistance that's a little higher than a more expensive one. Over here, we would like our internal resistance to be a gazillion ohms, right? But in reality, they're probably going to be about 10 million ohms for a decent voltmeter. And for a decent current meter, we're looking at something like 0.00001 ohms, something like that. So let's do a simulation and see what this voltage and what this current are. If I click on this meter, here's the display for it. I'm going to measure voltage. I can measure current, that's A for amps, or voltage, or resistance. Now, to measure resistance, I can't have a battery connected to it. But this is AC voltage because it's changing. Here's DC voltage because it's not going negative, and positive and negative, just all one level. And this meter, we want to set that up as a current meter. We're going to measure amps. We're going to measure DC amps. Now, remember in your spreadsheet last week, you did some calculations, right? You learned that voltage equals current times resistance, and that current equals voltage divided by resistance. You did some calculations. Let's do some measurements now to see what this circuit will do. In order to simulate it, we run up here to this green arrow, says run, and click that green arrow. And this meter is measuring 2 volts. That means this side is 6 volts, right? We knew that because compared to 0, the top of the battery is 6 volts. This wire is 6 volts. And this wire is 2 volts less. We're measuring the 2 volts difference between those 2 wires. That means this wire is at 4 volts because it's 6 minus 2 is 4 volts. The current that runs through there is going to go up to this meter, and it's measuring at 2 milliamps. Well, if you have 6 volts divided by 1,000, 2,000, 3,000 ohms, 6 volts divided by 3,000 ohms is 2 milliamps. So that's how you build a circuit and how you simulate the circuit. And you're going to do it. You're going to do a bunch of them. I think like 10 of them. You're going to build some circuits and see how they work. Now, of course, I changed the battery over here to 6 volts. Yours is going to look like 12 volts, right? So let's change it back to 12. And now we simulated, these should both double, right? Because we doubled the voltage. Hopefully, because you have instructions, right? The written instructions, but hopefully if you've seen someone do it, you won't have as many questions. Oh yeah, I remember seeing how to do that.